In this session, we will discuss about electric field lines. So what is an electric field line? So suppose if we consider a point charge plus Q, the electric field lines are drawn something like this. So here the direction of the field lines in this case is radially outward. So if you look at these field lines, it gives a visual representation of how the field is distributed. So at any point at every point in the on the field line, the electric field is tangential to this line. So suppose if we consider this point here, the electric field at this point is tangential to the line at this point. Similarly, at this point, the electric field is again tangential to the line. So the electric field lines give us information about the direction of the electric field at all the points, and also it also gives information about the magnitude of the electric field intensity. For example, if we consider the unit area here, the number of lines passing through this area will be less than the number of lines which are passing through a unit area which is normal to the field lines here. So the density of the lines will give an idea about the magnitude of the electric field. So by looking at this, we can say that the field intensity here is more than the field intensity here. So the electric field lines give us information about both the direction of the electric field and also about the magnitude of the electric field intensity. So suppose we have an isolated positive point charge plus Q here. In this case, we can see that the field lines are diverging from the point charge, that is positive charge. So the field lines start from a positive charge. So let us take this as case 1. So let us consider another case. So here we have a negative charge Q. So here we can see that the field lines are drawn like this, but the direction of the field is into the charge, that is here the field lines converge to this negative charge, or they terminate at this negative charge. So the field lines either they start at positive charge or they may in some cases start at infinity, and the field lines may terminate at negative charge or they may terminate at infinity. For example, in this case the field lines are starting at positive charge and terminating at infinity, whereas in this case the field lines are starting at infinity and they are terminating at negative charge. Let us consider another case where we have two charges of equal magnitude and opposite polarity. So let's say we have a charge Q1 which is plus Q and charge Q2 which is minus Q just at this point. Now let us consider the field along this line in joining the two charges. So here we can see that suppose we have a point here. So at this point the direction of the electric field due to plus Q is in this direction, because a unit positive charge placed at here at this point will be repelled by plus Q, and whereas it is attracted by minus Q, but this magnitude will be less, whereas the E1 will have a higher magnitude, but the direction of the net electric field is along this line. So therefore the field line here is in this direction. At any point on the perpendicular bisector of this line, see here the electric field at this point due to Q1 is in this direction, and due to Q2 is in this direction. It has the same magnitude, but the direction is as indicated here. So we can see that here the vertical components of E1 and E2 they get cancelled, and the horizontal components will add. So at this point the direction of the electric field is horizontal now. So because of symmetry consideration, even here also the direction of the electric field is in this direction. So the field line which is starting at plus Q will be terminating at minus Q. So we can complete the field lines. Approximately it will look something like this. So we can observe that the field lines are starting at plus Q and they are terminating at minus Q, and the magnitude of the field intensity here is more because the density of the field lines is more here, whereas the electric field intensity here is less. So to conclude, we can say that an electric field line is a line which is drawn tangent to the electric field vector at each point in space, and at every point it has the direction of the electric field. So the direction of the electric field line is same as the direction of the electric field, and the number of lines per unit area is proportional to the magnitude of the electric field intensity. And we can say that if you leave a small positive test charge which is placed at any point in electric field, and if it is free to move, it would accelerate in the direction of the field line passing through that point. So let us consider one last point. Suppose if we take this case where we have two charges plus Q and plus Q, then at the midpoint of the line joining these two charges, you can see that this first charge is producing a field in this direction, that is repelling, and this second charge is producing a field which again is having the same magnitude but in opposite direction. So therefore the field here is 0. So this point is known as null point. So field line does not pass through a null point.